Hello, all. Good afternoon. And my name is Ashish. I work as an software development engineer in Uber. So today's lecture actually we are going to talk about arrays data structure, which is one of the important topic when it comes to data structures and algorithm. And it's uh, mostly uh, what do we say, like most of the questions that are being asked in our companies are from arrays. And I've seen companies like Walmart, companies like Goldman Sachs and Adobe, etc., have asked me, at least one question of arrays in interviews. So this is definitely one of the most important topic, but we are not going to discuss all the problems here, what have been asked and all, because there is no point of mugging up one or two or 10 problems. We are here to discuss, the arrays in deep, like how internally it works and how will you develop the thinking, and what are the difference, why other data structures are preferred over arrays, why arrays preferred, how dynamic arrays created, all those things. So let's start. Okay. So when it comes to arrays, the first thing which we should know, that how uh, arrays are internally represented, like why, when we are using, how internal working happens. But before that, I'll give you an introduction of array, which already I think everyone should have known. But yeah, so array is a linear data structure that everyone might be knowing, and it stores the elements, or it stores a group of elements, right? Group of elements of same data type. So what do I mean by same data type is here is, so let's suppose if you have created an array, you have to specify the data type of that particular array. That means that all the elements which will be stored in this array will be of same type. For example, if you are saying that you have a array of integer, okay, so here what, all the elements will be of type integer. So 1, 5, 8, 9, 2, 11, 15. Okay. So it won't be possible for you if you are declaring it as integer array and you are storing it like you are storing a character, or you are storing any other, like maybe float or anything, right? You cannot do that. Uh, the reason behind this is being, I'll explain when I'll explain the memory context of array. So just remember for now that integer array will store integer, string array will store in strings, character will character, all those things. So you have to pre define that data type of that particular array. And why it is necessary is, like, so when you declare an array or when you work with an array, right? How does it, what do I mean here? Okay, here I said that it is a linear data structure, and uh, it stores the elements in elements of same data type, and it requires a contiguous memory allocation. So this is the important word, that it requires a contiguous memory allocation or location. Okay, so what happens, so when you see this array, right? So what does it mean, like when we create that array, like this is the first block of memory, this is the second, this is the third, this is fourth, this is fifth, this is sixth, and they are adjacent to each other. So let's suppose, let's assume that this is your memory representation. Okay, so if you would have known that every block of memory. We'll give Diksha. Okay, so arrays, if you are asking that real life application of array is like everywhere where I have code, right? Like you have to store your data minimum in the list, and list uses that list is a kind of array, like array list or anything. Like for example, like if you want to pass this, for example, I worked in Walmart, and there are lot of applications where there was a number of stores, for example, are passed, right? Walmart has limited number of stores, for example 4,000. So their store IDs, when we pass to get the details, uh, these were the part of you know array list only. Like if we want to uh, store them and do some operations onto them, so since they had a limited stores, and we know that it's 4,000, and if they will increase also, it will take time, like to open up a store, it takes a lot of time. So 4,000 to 5,500 is still in a range, so some kind of that. So this is a practical life example of this, of arrays, if you're saying. So there are ample of things, like every day when we code, you need some data structures to hold your data which is coming, hold your data on which you want to do a operation. And if it's limited, we kind of use list, array list, or array in any language. Okay, so that's the kind of practical example, since you asked uh, here. So let's go here. So let's think that this is our memory, and you know that every block of memory has a memory address. So for example, this block has memory address 2000. Okay, and let's suppose, if let's consider a character, or let's consider, okay, integer array. Okay, and let's say that this is 2000, this is that memory address is 2000 for this. And let's consider that there are four blocks of 1 byte. So this is 2000. Okay, let's delete this, sorry. Okay, and what will be this one? Since this first block is smaller one, are you able to see, right? So this one will be 2001, because byte, we are taking this of 1 byte. Okay, so one block we are taking of 1 byte. It can store the element which has size 1 byte, and 1 byte equal to 8 bits. So bits is nothing like, you might have heard about bits concept, like 16 bits, 8 bits, 32 bits, etc. Bits are nothing but like the smallest unit. And if I'll give you context in terms of very real deep, that is like 1 bit is kind of, you can understand that there is a one wire on that particular chip or transistor, whatever it is internally. So let's suppose if they have 8 bits, right? 7, 8. So what happens, like uh, if the voltage, so computer understands only zeros and ones. That means either in terms of electricity, how this is some deep. If you don't understand also, that's okay. But 0 and 1 means this has no voltage, and this has voltage. Okay, so that's how it determine. And what happens, so it is kind of binary, right? So if you want to represent, let's suppose 1, so you will say that this is on means that this, so this is how binary representation looks: 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Okay, so if you want to represent 1 in binary, so all of these will be having no voltage, that means 0. And this will be having high voltage, like there is electricity present, that means that is 1. So when you write it like this, right, 0 0 0 0, and this is 1. Okay, so that means this is representing 1. if if this is also 1, so this is equal to 1, obviously. And if there is 0 0 0 0 0 1 0 0, okay, so this is at the position 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2. So what will happen here? This will be 4 and plus 1, this will be 5, correct? So that's how it works. So that's how it is being represented. So let's not go much deeper in that, but here let's suppose this is of 1 byte, this will be 2002, and this will be 2003. Cool. So what will happen now? Let's when we declare array of integer, so what is the value, what is the size of integer size is, for most of the compilers it takes 4 bytes. Some compilers earlier used to take 2 bytes also, but now it is made 4 bytes to increase the range of that. So in Java also it's of 4 bytes. So let's suppose uh, when we are declaring an array, so what happens, like this is the memory. Let's suppose this chunk is filled by some other process or program what is working, and this chunk is filled by something else. Memory can be filled like based on internal processes and all those things. So when you run your program and when you say that you have an integer array, okay, of size, let's suppose 5, for example, integer array of size 5. So in the memory, since let's suppose this is also filled, okay, so in the memory it searches that where it will get the contiguous allocation of integer for integer array whose size will be 5. Okay, so it will search 5. You said that 5 integers should store, and one integer will take 4 bytes, right? So similarly, 5 integers will take how many bytes? They will take 4 5s are 20. So they'll take 20 bytes. So it will go and search for contiguous allocation of 20 bytes. Okay. So we considered this block, this one block we considered of 4 bytes, right? One byte, like I have shown here. So it will search for such 20 bytes. That means it will find it somewhere here. Let's suppose that's the work of operating system and all those processes, which you don't have to do anything. That languages take care, that gives the command to operating system, and that allocates memory for you. So it will, let's suppose it found this block for you. Okay, and what it will do, it will block this. So now let's suppose you have written a program, you are running in memory, that's block for you. Let's suppose some other process using your memory and using the same process and all, if that comes and that wants to occupy, even if you have written anything or not, that's a different thing. Once the memory is allocated to your variable, your array, so this will be like this will block this. And what will happen, next program, whoever comes, they can, maybe if they need 3 or 2 bytes, whatever, they can use this one, they can use anywhere. Like it depends on their memory management of OS, like wherever you want to use. That doesn't this will not care. So that's why this is one of the reason, whenever you declare, we are not talking about dynamic arrays, we will talk about array list later. So just listen. So that's why it is important. So you can try declaring an array without size. It will give you error. It will give you compile time error, that it is not possible. You have to tell. So that's why, because it blocks the memory. Okay. So now if you will see that how it works from here is, now you have seen you have blocked this memory. Now this ARR, this is your reference. Okay, reference variable, whatever you can say it. And when you do something like that, so int 5 ARR equal to new Okay. And so when you do that new, right? Or if you don't want to do new, you can write here also if you want to do like this. Int ARR 1, 2, 3, 4, 5. There are many ways. So once you give the values, or once you use this new variable, okay, new allocates memory, then this continue continuous block will be allotted to you, and you will be uh, you know uh, be able to store the values in there. So now let's suppose whatever values you want to store, 5, 5, 9, 2, 1, 6. Okay. So this you will be able to store. Let's delete this, and let me tell you here. So now this is your array reference, and it will point to this. So point means that this will have your address. So let's suppose this was, I said, 2000. For now, for simplicity, we are taking this is as 3000. Okay. So these I've assumed. Don't think that this is a virtual memory address and all those things. This is a complex number. It's not that simple. So let's suppose this is 3000. Okay. So when you'll say that ARR, that means it has 3000 memory address, and whatever the value, it will fetch you. Okay. When you do ARR 0, that means 3000 plus 0. Okay. That gives you the value of 5. This is the memory address. Now when you do here, when you do ARR of 1, so ARR is pointing to 3000 memory address. Okay. What ARR will do? What ARR will, can someone answer? 3000 plus uh, okay, Karan said 1. Any other answer? Ahmad, the notes I'll share with the Geekster. They will give you. And recommended material, reading material. I don't think so that anybody has explained this on any tutorial and all. When I was working, when I was studying, then I explored all those things. So yeah, whatever material I know, I'll tell. So somebody said 4, Madhav said 4, Sumi said 2, oh, and Sanjay said, okay, 3004, he gave final answer, but I wanted to ask your value. So Madhav, you're right, like 4. Why 4 here? Why, Karan, why not it is 1? Why not it is 2, Sumit? And why not it is 6? Because when I said that integer takes 4 bytes, okay? So what will happen? 5, this 5 will acquire 4 bytes, this whole block. So 1, 2, 3, 4. So here 3003 will be there, and this block, starting of that block, will have address 3004. So our next value is, this is not a value, by the way, this is memory address value. Okay. The actual value which is present on this particular address 3004, this is an address, okay, is 9. So that's how the value, once you will do ARR1, this will give you 9 by fetching it from this location. Okay. So that's how it works actually. So that is why it requires the continuous allocation of memory, because it has the address of this one. It has the address, when you declare a reference, it has the address of this one. And what it does is, when you do ARR of, let's suppose, 4, so it knows it is of type integer, size of one integer is 4, and what it will do is like 3000 plus 4 into 4, 4 cross 4, one is integer size, one is this fourth one, and it will say 3016. So whatever at AR of 4, 1, 0, 1, 2, 3, 4. So it will fetch you this 6. So I hope everyone understood this, right? Can we get a yes here? If you not understand, okay, Sumit. Thank you. So now see that this, so literally, like, this comes with some advantages and this comes with some disadvantages. Now let's see, like what all the advantage of this data structure. Okay. So advantage of this data structure is, like, if you know the index, if you already know the index, you know that you have array of, let's suppose you have, your school is having, just an example, your school is having, this is not how data will represent in big systems, but example, like school is having 500 students and they are sorted by their roll numbers. Okay. So let's suppose ARR of 500 you are there. So, and it's of a string, for example, and you know that this is sorted by their roll numbers, not by string. Okay. So zero, one roll number will be present at this index. Let's suppose Ashish, or whoever is there. Okay. Then Ashish, any names you can take. And here, let's suppose there is Ravi. Okay. 0, 1, 2, 3, 4. So you know that Ravi's, whose roll number is fourth, you want to query. So you can say that give me ARR of 4, example. So it will give you Ravi. Okay. This is how. So I just wanted to tell you the advantage of it. Advantage is real quick, that if you know index, okay, the search complexity here, time complexity I'm talking about, not space complexity. The search complexity of that particular operation becomes O of 1. Why O of 1? You don't have to iterate. Okay. This Kalyani, why it starts from zero? I think when Dennis Ritchie was, I think, doing C, I don't know the exact reason for it, but I think where when I researched about that, Dennis Ritchie uh, is like, when they were doing a programming paradigm or writing compiler, this is how, and they started. And the reason now, that why the calculation looks like the index 0. So here, if you'll see that logically, that this is the array, right? And when you point this out, so this is the zeroth index, correct? Why this is a zeroth index? Because you don't, so this ARR already have 3000 memory address. This is memory address of that, pointing to, this reference is pointing to 3000 memory address. Now when they created that, like invented or whatever that data structure, so they wanted that, right? Like how it will jump to next, element, right? You can't store in one reference, you can't store all those references, correct? You will have only initial index. So if you want to jump from here to where next one, so what they did is, like, 3000, and if it is of 4 integer type, okay, 3000 plus 4 into what? AR of 1 ke liye, into 1, correct? So similarly, for first, for getting first, when you will iterate like this, ARR of 0, ARR of 1. So you will get here the second element, this one. Okay. So for first, 3000 plus 4 into 0, this will give you 3000 itself, because you cannot make it generic for every statement, like zeroth for 0. You will have to use a programming concept here also. So that's how I think the compiler is written. That's why it's always starts from 0. That's what I know. I hope it is clear and it's logical, right? Okay. So moving ahead, I was telling the search complexity of the search complexity of any element in the array, if you know the index, knowing the index, okay, is O of 1. And then if you know the index, you can easily replace. So replacing, editing, all becomes 1. But the problem, like, and it is very much suitable for the data which we know is limited also, kind of, correct? So these are the few advantages which we leverage for array. And there are many disadvantages also. So for example, where this was asked in live interview from me, I think Walmart's only, uh, or lending card, I forgot the name, but the question was like, let's suppose there are millions of data, okay, but we don't know the we don't know how much kitna data hai, we don't know, but we know that the data every hour or every 5 hours 6 hours, the data comes in batches of 1,000. Okay, so here, uh, the data comes in batch of thousands, but we don't know how much data we have, but batches of 1,000 comes. So what this is the information we have, and we want you to store this data, write a program which stores this data, and give me that data in memory, not in database and all. We will not go there. In memory. So what will you do? Which data structure you will use? Can somebody answer for this particular problem? Can I get one or two answer? Like, you would have studied data structures, right? Dynamic arrays. Okay, one thing is, let's keep aside the concept of dynamic arrays. Dynamic arrays are also created by array itself. Yes, Rishabh, Rishabh is right. That linked list will be better here amongst the database. We know what is the limitations of dynamic arrays, Ravi. I'll explain that also when we'll give an example of array list. Array list is a kind of dynamic array which grows in memory. How it grows, I'll tell you internally. Yes. So Ishika, no, array list is like, if batches of 1,000 comes, right, and you will declare an array of 1,000, correct, here. So you don't know. Let's suppose you declared an array of 10,000. Okay. So after 10th batch, 11th batch will come, right? Where will you store that? Correct. So you will use here linked list. Ankit and Ajinkya, all those, Rishabh, whoever gave the answer, linked list, which is true. So this is the advantage of linked list. So when in the memory, linked list does not require contiguous space. Okay. So let's suppose this is the memory representation, and if you are declaring a linked list, so linked list can be like this. There can be one node here in occupying this, and one node, like, just giving example, and one node, okay, one node can be this, and this will store the address. Okay, one node here can be this also, so this will have its address. One node, it can have been here, wherever that memory will be there. Okay, so linked list will be better because first 1,000 came, wherever it will get memory, it will allocate, and next 1,000 will come whenever they will come. How much they will come, it will depend on your total memory, but it will not require continuous allocation. So that's one of the major advantage of linked list. Since we started this topic, I'll tell you a bit about linked list, but then we'll switch to arrays itself. So linked list contains a node where there are in the node there are two types of data structures used, correct? Space complexity, I'll say arrays space complexity is better, because for linked list it requires, like, here it will be int, right? So this will be int, and this will be of type node itself, because it will store the address of that particular node, next node. So let's suppose next node is here. This is at 3,000x. This might be at 5,000x, and here it is 5 integer, and this will have 5,000x. So it knows that the next element is 5,000x. So definitely linked list will take more space. So space complexity wise, it is not very good. But what you're saying, like it doesn't require a contiguous allocation of space, correct? So that's one of the advantage of linked list. And let's suppose next is at your next element is at 2001x. So it will have 2001 2001x and data like 9 there 10. And if there is nothing, then it will have null. No, if the linked list is ending here. So like this is pointing this is pointing to this. So this is how linked list works. So linked list does not require this contiguous allocation. So that's one of the major advantage of linked list over arrays. And but here in linked list, the disadvantage is that you cannot do operations based on the index, even if you know. So let's suppose I created a linked list. Okay, let's suppose I created a linked list here, and let's suppose I have this 10 at, if you can start 1 to anything, 0 1 2 3. Let's suppose this is 3. If we are starting from 0th, let's take head of 0. Even if we know it's at third position, we can't directly get the data in of OFN. Why? Because we will have the reference of head, correct? And this doesn't work with the concept head equal to what will do head plus if there is 0 1 2 3 4 4 into 4 heads location plus 16. This will not work because this is not true. This is not contiguous, correct? So this funda fails here. So that's why what we have to do is we have to iterate that linked list. So search complexity in linked list, even if you know the position, you know the index, that will be O of n in worst case. Like you have to iterate n elements. But you know the benefit now of linked list. So if you guys got the gist of internals, we can move ahead with other things. Can I get some yes? I want to make this class a bit interactive one. So that's why I want to know that people are listening and people are getting what I'm telling, right? Okay, cool. So this was the 1D array memory allocation, correct? Like if it is starting from, let's suppose, 5,000. So next node will be for, I'm talking about integer. I'm taking, if it is character, then 1 byte. If it is more than that, if it is long, if it is other data structure, like if it takes 8 bytes, so then it becomes 5,000 plus 8, like that. I hope you got it. So 5,000 plus 4 is 5,000 plus, let's do 1 like this so that you will understand. Okay, 4 into 2. This is how memory will be allocated for this array. Okay, 1 2 3 4, like this. So this will become 5,000. This will become 5,004. This will become 5,008. This will become 5,012, and like that. So this is how it is stored for array. And now you can wonder that how uh, 2D arrays allocate that memory. What will be the index? So let's test some fundas which you guys have. So let's suppose this is a 2D array. Okay. So what it call it? Rows into column. How many rows? 1 2 3 4 5. 5 into 3. This is a 2D array. Okay, array of 5 rows 3. So let's start. Let's say that this is at 1,000. Okay, 1,000 one. Let's do 1,000 for simplicity. So can anybody for loop iteration for storing 1,000 elements in that problem in an R works, right? Sorry, Ravi, what for loop iteration for storing 1,000 elements in that problem in an R works, right? I didn't get it. How many? But oh, okay. You are saying that if you are looping, uh, how will you end that loop if you don't know that how many batches you are coming in? Can you answer? On what basis you will end the loop? What will the end condition of that loop? Or will it run every hour? Or is it an infinite? If that's the case, because we don't know array dot length array, you are saying that for storing 1,000 elements in that 1 hour, you will create one array, right? That's okay. And you are saying that when the next 1,000 will come, where will you store? No, Sanjay, you are getting wrong. Ravi is saying that 1,000 elements will be stored here. Then again, 1,000 elements will be stored in another array. This will be array 2. This will be array 1. He's saying that he knows that 1,000 elements come in 1 hour batch. He will loop it, right? That's what I understand. There will be error 3. So how many arrays where will you end this loop, Ravi? I hope you get the answer. Since we don't know how many batches there will be, there are millions of record. We don't know. We won't be able to end this. Like we can't create infinite arrays, correct? So I hope you got that answer, Ravi. So moving ahead here, what I was explaining is what I was explaining here is if this starts at 1,000, okay, cool. Can somebody tell me the address of this, since it is a 2D array? What will be this one? This is 0, 0, 0, 1, 0, 2. Okay, 0, 1, 2, 3, 4, 0, 1, 2. So this will be 2, 1 index. Okay, so what will be the memory of this? Can somebody quickly do it for me? This is integer. This is integer array, which is a 2D array. Okay, somebody said 1028, Madhav. Okay, I also have to calculate, but yes, let's see other answers. 10028 is the correct answer. I hope everyone is now getting the gist. Correct, Vidhi. It's 1028. How? This will be 1004. This will be 1008. Similarly, this will be 1000. Sorry, this will be one. What is happening? This will be 1012. This will be 1016. This will be 1020. This will be 1024. And this is how this will be 1028. Excellent. I hope everybody understood. So this is the 2D array memory allocation. This is very, very simple, and that's how it works. So this, you can call it metrics, anything. So this is all clear with you guys, right? Let's move ahead. If anybody has doubt, whoever has written 1028 got the answer, but is there anyone who doesn't understand this particular allocation? Because this is very important. If you know the internals, only then you'll be good in terms of applying the data structures in real life, that which data structures to use and where. Okay, I am assuming that everybody understood. So moving next, if I'll say that where okay, next I'll say that okay, so this is kind of gist of arrays, right? But in industry, you will not you will have to have the deeper understanding, deeper knowledge of array data structure, not only array, all the data structures and algorithms, so that you will be able to code that. But what happens, like somebody asked earlier, that real life example also, the data structure is a very smaller part of that, correct? Like you need to learn the frameworks. When you learn a language, let's suppose you learn a language and you want to be a backend developer, so you need to learn a framework along with that. For example, Spring. If you have learned Python as a language, then you will be learning Django framework on top of that. And when you will code using all those things, in that there will be a smaller part where you will be using data structures to store, to manipulate the data, all those things. So similarly, if you want to get into the front end, and if you want to learn, for example, React, then you have to, oh sorry, you learn the JavaScript or TypeScript, you have to learn a framework called React, or framework Angular or Node, whatever like available. And if you want to become a full stack, then you have to learn some technology, some framework of front end, some framework of back end, and you need to have the understanding of whole. So that's how the real industry works actually. And and I got to remember that even Geekster, I think, provides some demo classes that how to become a full stack developer, and what all things you can learn to become a full stack. So you can definitely uh, attend that demo class also. I don't know when it will be happening, but maybe Geekster's representative will give you that. If somebody is there, they can share you the link or something on your emails or chat right now. So that will be helpful for you guys to see that how can I learn different frameworks along with data structures and all, like full stack development. How can you enter? So that's one thing. But moving back, this is how memory allocation works. Now if you'll see the use of arrays, I told that how you use arrays in the industry, but how arrays are used in other data structures is like, so for example, you have array, and you might have heard about data structures like stack, data structure like queue. Okay, so these data structures can be constructed from array, and so they can also be constructed from linked list as well. So you know now that what are the advantage of this, what are the advantage of this. You can create this stack, and everything like double queue vector, uh, many applications which can be uh, you know um, use arrays like other data structures. So now you stack and queues are nothing. Like stack has its property, queue has its property. Queue is first in, first out. Whatever element will be inserted first will be out first. And stack is yeah for last in, first out. So what is the meaning of last in first out is like whatever element is inserted at the last, it will come out fast, or you can say first in, last out. Whatever element is inserted first, it will be last. So for example, let's say if अगर आपने बचपन में like देखा होगा तो stack of notebooks. So some people used to take out the notebook from middle and put it on the top so that it can be checked. But in computer science it won't be possible. So here if you're there, so इसमें वो वाला फंडा नहीं चलता है कि यहाँ से निकाल के इधर रख दिया. So you have to pop all these to get this particular done. So yeah, a stack of notebooks, stack of plates, anything. And queue, that railways mein, if you are going for reservation physically, now it happens on IRCTC, but that also happens in a queue only. Like when you sir, we would like in Hindi this session. Diksha, actually, I'll be using English. Why? Because I don't know that how many people understand Hindi, right? And there might be few folks who might not understand Hindi, and they know some other language and English. So I can use Hindi sometimes, but like I'll prefer to stay in English so that and everybody can understand, right? Like so, so railway queue, like whoever went for first for the reservation will get it first, and then it will move. He or she'll move out, and the next person. So like that, array is also used in that. So we'll not go in that detail that how it is being constructed, but I can tell you. So yeah, so yeah, I'm continuing in English, Durga. So let's suppose this is let's suppose this is a vertical array, for example, and index is 0, 1, 2, 3, 4, 5, 6. So when you will write a wrapper, right, using using array, what will you do? You will internally create an array only, okay, and that array you will restrict by your program that that if somebody says get me an element pop, you'll write a pop karke, okay, then you will be uh, so for example is 1 5 4 9 2 3. So you will see first that you will see if you're popping an element, you will see that till what index it has till fourth index, so you will return the last index element. So that's how you create element element index element. So that's how you create stack and all. We'll not go in detail, that comes as part of lecture, where you learn stacks in details, and where you know learn that how stacks are created using linked list, and using linked list also same. So here you will have, okay, and you will have head, you'll have tail, and you will always push an element through tail, and you'll always pop an element through tail. So you will not expose this head to outer world. Only from tail you will if somebody wants a data, you'll say that this is the data, and you can pop it from here. Or to make it simplified, now the problem here will come, like how will you have the back? So let's suppose you have popped the data from here, how will you reach here? So what you can do, that's how you should develop a thinking also uh, of developing edge cases, okay. So edge cases, thinking in terms of edge cases is very important. So here I said that okay, push through tail, pop through tail, but now what is the edge case will, so that's why I told you. Now what is the edge case that you will encounter problem with? You'll say that how I will get this, okay. When you pop the element from here, how you will get this data, because this won't have the reference of this. So here you can also use doubly linked list, okay. Which what doubly linked list does, every node has information of its ahead's node and its back nodes as well. Back node will be null, something like that, okay. So this is a doubly linked list. So that's how you use. So why I'm saying that, okay, so whenever, so this is an interview tip and very important. So when you want to give interviews for big companies like Fang, Mang, etc. So what they see that how clean your code is, how much time you have taken to code. That there are a lot of parameters. Like first is time you took. So if they have given you medium level problem, they expect you to write the code, etc., in 40 to 45 minutes max. And if you are giving Google's interview, they expect that you write it in 25 minutes, because they ask two questions, 50 minutes, two questions, and 10 minutes intro and understanding question, etc. So that's the expectation. Time you took, how you communicated. Then third is things they give you points on, like whether you have used or identify correct data structures. This is very important. That's why I said, like, if there is a use of linked list and you are using arrays, this will be a negative for you. So how much best data structures you have used, and your algorithm, is it optimized, is it semi-optimized, what it is, all those things. And last, your code is working or not. Like let's suppose you have chosen this also, algo also, but when you implement it, it's not working. So that is also a bit negative, or it might be considered as 50% half, that you are not able to write working code. So all those things are considered. So when you will write, when you'll understand, you should understand that uh, the internals of data structures in such a way that it gives you the picture that whenever you do any question, you will get to know that this is the best suited data structures. I see something is posted on, so we'll get notes in class. So yeah, but this I have answered earlier. This notes I'll give to Geekster and they'll give it to you. And the study material is like I'll tell a few things, but like this class will be enough for you. After that, you can start solving questions itself. So arrays are also like most important things that that comes like algorithms where arrays are most yeah, heaps also, like yes, there are a lot of I might have missed few data sets like heaps and etc. They can be used. Arrays are the one that's are used. So here like first and foremost is like searching algorithms mostly. That comes with a example of array, and whenever interviews ask some questions about it, they'll tell you that this particular thing that uh, can you search an element in an array, and then there are variations of this, the linear search. Okay, and then there comes binary search. So you should know these also, like linear search, binary search, what all this. I can give you a gist of it. And then also in sorting, it comes like if you want to sort a particular data and it's stored in the array data section, like there are multiple algorithms, like there is a which company will talk about it later. I'll give 15 minutes Q&A at 12:45. We'll discuss all these concerns and questions, Saksham. Yeah, that's really great if you have started preparing this. So sorting mein, what happened here? Sorting mein there are algorithms like quick sort, merge sort, okay, and like these are the bit advanced. Bubble sort and all are bit of beginners level. And there are a lot of actions, selection sort, insertion sort. So we cannot go because explaining quick sort or any sorting algorithm will take, yeah, topological sort, correct, will take around 1 hour. So I'm just telling you just where arrays are used and how important it is. So like I'll give you one good example of these things, okay, so that you understand that how questions are asked. So nobody will ask you like, can you write a bubble sort or can you write a quick sort? That used to be the case, I think 10 years back, like 2013, 14, 15, when they directly used to ask with some modification, like, can you do a search? Can you write a code for a linear search? Can you write a code for binary search? Now the standard has been, changed a bit. They give you a question where these algorithms, uh, you know, these algorithms gist or implementation is being used. It's not directly they'll ask that do this, but they'll ask you questions that you will think upon it, that what should I use. So for example I'll say that binary search, okay. So everyone knows binary search, that if array is sorted 5, 9, 12, 15, 20, and you want to search an element, what you will do, you'll divide it mid. And if your element, let's suppose I asked you to search 9, so you'll see that your mid is 12. And if your given element, which is 9, is less than 12, so you will search here, okay. And if it would have been 20 and it is 12 is greater than 20, sorry, my bad, 20 is greater than 12, so you will go in right. So if element is greater than mid, then you should search in the right. And if it is less than that, you search in left. So binary search के लिए सबसे फर्स्ट क्या है, यस रवि, सो बाइनरी सर्च के लिए सबसे फर्स्ट कंडीशन क्या है, that your array should be sorted. So this is first condition. And uh, now you'll see that then they'll ask that why binary search, why not linear search. So when you linearly search, you have to search all the elements. So the complexity of that will be O of n. But when you are doing binary search, so at every iteration, what you are doing, you are minimizing, or you are doing the search set dividing by 2. So if first time there was, let's suppose, 100, in the next iteration there will be only 50. Okay, and there will be next time there will be only 25 example, and that's next time there will be only 12 or 13. Depends on if you take int, mid, and all, divide by 2. So if 12.5 is there, it will take as 12 only. Next time there will be 6, they will say. So you will not have to search all the elements. Okay, you will have to search the elements. When you do half and half, like if you have n, then n by 2, n by 4, all those things, the formula that comes, this is a mathematical thing, we're not going to derive that, but the algorithm's complexity comes log n. Okay, O of log n, logarithmic n, correct? So that's how things are searched in binary search. And why it is introduced? Because it is faster than linear search. You can always search uh, from 0 to n in a for loop, but that will be having complexity of n. So now somebody will ask in interviews, if somebody will ask you a question, okay, so they will not ask that, hey Saksham, or hey Ravi, write a binary search problem. So how you should understand the mindset of interviewer. So they will give you something that they'll not say directly use binary search, directly write a code for binary search. If it is very very trivial, very very simple interview, they can still say that, okay, you have a sorted array and you need to search an element, can you write code? So you have to first understand the question very clearly. They'll not mention mine is that. So one person I interviewed a long back, and when I gave this question, this is the very very simple question. It was the telephonic screening round, and this guy started writing for 0 to, you know, length of array, I less than ARR length, and this guy did in 1 minute and said that, this is very simple question. I did not expected this simple question. So I literally, from inside, I said that, okay, either he doesn't know that how to apply things, or he didn't read the question. So I gave him the hint also, that is it right? Can you optimize all those things? So he's saying that this is the best place, but he ignored this. And I will say, I'll give you this, but I'll not say binary search. But then after some time I'll give hint, but that will be very strong hint. And if somebody don't know this and not paying attention, it is really a negative for me. And the simple question for every interview, right? So you should need to uh, give give a thought while solving questions related to data section and all that, what all keywords are there. They will give you the hint which things to use, correct? So this is one of the example. But if they want to increase the complexity, so they will not say it's sorted, because now, everyone who is preparing will know. They'll say that you have a rotated sorted array. Okay, you have a rotated sorted array, and they'll give you like something like that. So for example, if you have 1, 5, 9, 10, 12, 15, 19. So they'll say that you have a rotated sorted arrays like this. For example, 12, 15, 19, and 1, 5, 9, 10. Okay. So this is the array. Now you have to search an element. So you see that now it is still a sorted array, but it got rotated. So you can see that from here it is rotated. So you should understand, you should see that binary search will work here in some manner, but you have to twist that binary search. After solving a lot of problems, you'll get the understanding of these things. So what we'll do, this will be called rotated point or pivot point. So now you will focus on first, if you can find a pivot point, that from where this particular thing array is rotated, by checking mids and all. So Ravi, and all those things who are answering binary search, if you know the binary search, try this question after this class. So you find a pivot point, and then you get to know that okay, this is the rotated part from the last of that. This is the rotated part of that, and then by tweaking the binary search, you will be able to solve this. So this is how you should practice. Okay. Hello. Can I get yes or no if people understand that how questions are formed into it? Okay, cool. And the other applications of such algorithms is like if you want to find a square root of any number, so obviously you can do, or square of any number like square root of 81. Obviously you can do 1 into 1 equal to 1, which is not equal to 81. You can do 2 into 2 equal to 4, which is not equal to 81. And where you'll say 9 into 9 equal to 81, which is equal to given element 81. You can say. So this is a linear thing, right? But now what you can do is like if you want to find something like that, try how you can reduce the iterations from 0 to 81, how you can minimize these iterations. Cool. So this is how you should think. This is how algorithms work. And similarly, let's suppose uh, mm, Ravi, okay, um, let's suppose this is the let's suppose this is the array. Okay, 5 9 1 2 3 4. So if I say that search an element, what will you do? Yes, so first using must sort to sort it. So first you are saying you will sort it. Okay, that's great. You sorted it. Okay. 1 2 3 4 5 9, and then you will use binary search. That's great. But is it a good approach for this? If you would have done linear search, what is the time complexity of n? What is the time complexity of this operation? Since you said, Ravi, can you answer? Correct. N log n. And n log n is greater than log n. Okay. Ravi, did you get it? If you have learned an algorithm, doesn't mean that you have to implement it everywhere. Keep it simple. O of n is far better than n log n. You are unnecessary, and Karan has said n log n, which is correct, but in actual it will be like n log n plus log n. Why this log n? This is of sorting, this is of searching. We ignore this part because this is smaller than this one, but actual mate is doing this. So it is worst to use this when you can have a linear search. So if you learned a binary search, doesn't mean that you have to implement binary search. For example, I'll give you, like, there is a 2D array, okay, and I'm telling that every row and column is sorted. 1 2 3 4 5 6 7 8 9 10 11 13 14 15 16, and I say that in 2D matrix you have to search. So you can obviously put binary search, but in 2D matrix it will be a bit complicated. But if I'll give you that rows be sorted hai and columns be sorted hai, then if I'll say that you can simply like this is like this is what this will be, 1 2 3 4 4 cross 4 matrix 16. Okay, you can use first, you can use here, and then you can use in columns your binary search, which is perfectly fine. But what you can do, there are other ways also to solve this. Okay, you can use something like that also, like uh, don't start from here, start from here, uh, start searching from here, and if the element is smaller, then reduce row, row minus minus. And if the element is greater, then do column plus plus. So let's suppose we want to search 6. What will you do? So 6 is greater than 4. So you will just come down like column plus plus. Okay. And now you will get 8. 6 is less than 8. You'll move here. 6 is less than this. You'll move here. You'll find this. Okay. That way, what will be the worst? What will be the worst complexity if you'll have to traverse how many elements? Only 4. Correct. Did you get it, or should I explain it again? You can use binary search here also, but see, this is very simple. This is very simple approach. So don't start from here. Always uh, think. Always try to think that what can be the better solution in the simplest way. What do you, Ravi? I think you are confused. Like, why this is BFS? We are not going into breadth or depth in this. We are simply doing a linear search with some restrictions. Like if it is greater than, then row minus minus, less than, rather than searching whole. Correct. So BFS and all concepts are a bit advanced, and it's like breadth first search and depth first search. It comes in something like if you have one node, let's suppose, and there are many nodes associated with this, not only tree, even if graph, and here this. Okay. So BFS comes in picture when you have starting here. You will either go in the depth. So if you have taken this, then this, then this, then this, till here you'll search. And this is depth. Or when you want to search breadth wise, so you will search all the elements which are associated with this one, then this one. So this is BFS and DFS concept. So here we are simply traversing through a 2D array in a fashion where just with the conditions, like if it is less, you can go here. If it is right, so everything, either you have to go here, from here, it's all connected here, right? This is not a non-linear data structure. This is a linear data structure. So they are adjacent, and this is connected with uh, two in the memory terms. Like here, or maybe maximum three. You can diagonally also process. That's not a problem. But how will you diagonally process? Like it will make your like algorithm very very complex. Correct. You can write here one more condition that if you can you can consider it with diagonal also, that whether your application or whether your element is greater than is smaller than diagonal, but we have to see and run that what all test cases, edge cases it will pass. So that's the one thing. So here when I was explaining interviewer, what interviewer looks for, they say that your code is working and all, and they say that if you have like covered edge cases and not. Okay. So so this is also very much important. And in practical, like I have seen a lot of things which fails during edge cases. We write program and we miss. It's really not possible to write a bigger applications like whatever Walmart's, Adobe's, or Uber I'm working in, to there are things which get missed and get caught in testing or even get caught in production. But that that's okay. But I'm telling that whatever program, this smaller program which you are writing, your program should be working on paper and not compiler. So always dry run your code whenever you have written on paper. Take few 5 to 6 example and dry run that this is how it runs. Okay. So that's about like how it works. So similarly there are sorting algorithms, and the best sorting algorithm complexity is n log n. Okay. So somebody answer also, Karan also answered. that when you'll use merge sort, you will get n log n. Okay, that's a different story. That which is better, quick sort or merge sort? So if you'll consider quick sort, quick sort's worst case complexity of n square, and quick sort's average case complexity is O of n log n, and merge sort's average is also n log n. But if you'll search on internet also, there was a scientist who performed uh, research on kind of this. They ran for average case, I'm saying, not for worst case. And most of the time the cases are average only, not worst. Worst is like all the elements are not sorted. It's completely in the other direction. So if I'll talk about average case, they ran he the scientist ran quick sort and merge sort programs on the same level of machine, everything same kind of program, and they found that quick sort was faster than merge sort. Okay, and this is like the complexity is okay, same, but kind of on the system they found that quick sort is a bit faster than merge sort in average case. So that's why people prefer for wherever you see that you will hear less about merge sort and you will hear more about quick sort. That's why people get confused that that worst case complexity of quick sort is n square, and for merge sort is n log n. Then why people use quick sort? Because most of the time the case is average. Okay, 99% of the time. And when it is average case, quick sort becomes faster than merge sort practically, although the complexity on paper is written as n log n only. That's one thing, but nobody asks you like this that okay, hey, can you write quick sort for me? How the questions are asked, and this was I think asked in renowned fan companies. So give me an let me give you one example for that. So here, let's suppose I'm the interviewer. I'm giving you that, hey guys, can you sort elements of an array which have data or which have integers, only integers, zeros, ones, and twos. Okay. So I want you to sort an array which will have one. Okay. So this is the one which I want you to sort. So can I get quickly get the gist? Think about people that how will you do this problem? How will you solve this problem? Can I get some answers? I'll wait for 1.5 minute so that you people get, and that's okay. Like you can give me a brute force also, Ravi. You can give whatever you want, whatever coming in your mind. Then I'll explain also. So don't think that, yeah. Okay, someone said selection sort. Okay, cool. What is the and please mention the complexity also along with that. Okay, the question is on the screen. We want to sort an elements of an array which have integers, zeros, ones, and two only. And you can see this is the array. Okay, you can put two here also, like anything. So it will have only zeros, ones, and twos, not not more than that. So this is the question, Karan. So how will you sort this? Okay, okay, Rakesh. One thing, and please mention the time complexity also, whatever you are thinking. I prefer merge sort. Okay, and log n, and Hari Prasanna is saying selection sort. Okay, oh, on to three. Okay, cool. Rakesh, I think Rakesh answer is good. Rakesh, you thought in good terms. Diksha, quick sort. What is the algorithm's complexity and log n and selection? Hari and Arpit. What is the complexity of selection sort? Worst or average case complexity? Yes, so Arpit, definitely n log n is better than n square. So people who are saying quick sort or algorithms with n log n will be better, correct? and Rakesh is claiming O of n into 3. Rakesh, you can actually 3 passes. That means it's not O of n cube, it's O of n plus O of n plus O of n, because there will be 3 passes as per Rakesh. So whose algorithm is better in terms of solving this question? Rakesh is right. Everyone agrees that how Rakesh is doing, I'll explain. And now I'll explain that why, how you can do it in one pass also, if you'll think. So see, now as I told in the earlier example also, right, that when you guys say that when I said ki there is a keyword given sorted, okay, then your mind should work like if it is already sorted, we can somehow leverage binary search, which we have studied. Here, I have clearly given you one constraint. If I would want to know your capacity to know or implement quick sort, or your implement selection sort, merge sort, anything, why would I have given this? I would have simply said that, can you write an algorithm to sort elements in an array? Why would I have given this? Have you thought about it? That if I have given 0, 1, 2, there has to be something different about this question. Did anyone think about it? No. So now you have only 3. So what Rakesh said is one of the good, and I would expect at least whomever I interview, I would have expected they should come up at least with this one, not if not the best one, but this. So what you can do, you can linearly traverse this array, let's suppose n length n, first time, and count how many zeros it have, how many ones it have, how many twos it have. So for example, if it has 1, 2, 3, 3 zeros, and it has 2 ones, and it has 2 twos. Okay. And now what you will do, you will replace in this array for the first 3 indexes. When you will iterate, 0, 0, 0. Now after this, you will iterate for they are 2. Okay, ones are 2 here and here. You will iterate for 2 index 1, 1, for other 2, 2. So this got sorted without any sorting algorithms, just in linear traversing. Okay, so complexity will come O of n. Although there are multiple passes, first you counted, and then you applied, but it is linearly happening. You are doing it only 2 to 3 times, and you are getting 3 variables. Here, store 0, store 1, store 2. Frequency, store frequency of how many times they are appearing. They will 3, 2, 2. So you can fill up like this. So did you get the gist that how you have simplified with this constraint? So I didn't want to see the knowledge of sorting algorithms. I wanted to see that how can you think and optimize the solution. This is, so did you get the gist here? Now this is one of the good answers you have reduced. But I say, if I say that, okay, no, so you are first counting and then replacing, you are taking more than one pass. Can you do it in one pass? So I just want people to answer that, to think for 1 minute and let me know that is it possible for us to do in one pass, or yes or no? Can we get a sorted array? We have to sort it. How can we get a sorted array? That's the question. Shakti, this is the question. We have to sort the array. If we'll get a sorted array, what we will do? Oh, you are saying, sorry, I think I understood wrong. You are saying, can we get a sorted array if you do iterate through array? If it is 0, swap it with 0th index element. if it is 2, swap it with an O. So, but okay, so there might be more zeros, na? There might be 10 zeros. Let's suppose there is an array of 100 elements and there are 10 zeros. So every time will you be swapping it with 0 on the 0th index? On 0th index, you can store only 1 0. You'll need 10. So definitely your algorithm has some glitch. You are thinking in a right direction, but your algorithm has a glitch. But Shaktini, you are thinking in the right direction. That's how somehow you can leverage the techniques like 2 pointers, 3 pointers, all those things, and then you can swap. So you are going in the right direction. Think about it. And it is possible, by the way. Diksha only said yes, nobody said yes, but yeah, it is possible in one. So Shaktini has thought in correct direction. And how will you do is here. Like let's suppose we take an example. Traverse the array, compare the element with the next one, swap if minimum, else continue. Okay, so you are saying that traverse the array with element with the next one, swap if minimum. Okay, so you are saying that okay, I traverse this. So now what you are saying that with the next one, okay, you said that 0. Okay, 0, I swapped it, and now 1 is here. Okay, and our pointer is 2. Okay, now you are saying that okay, we swapped it, now this is not less than, so our pointer is here, this is 0. Okay, so here it is less, we have to swap this. So this will be 0, 1, and since we swapped it with 2, here 0, here 2, what will be here? 1, 2, 2, 1. Okay. Now our pointer is here. Okay. So is this sorted? Will your algorithm work, Madhav? If we'll do just like that, you are thinking in terms. This is a classic example of bubble sort. But what happens? Bubble sort does not sort uh, L does not sort it in one pass. It sorts it in n passes. Okay, that's why it's complexity n square. Okay, no sir, what do you want to do? It's not right. So your algorithm has glitch. This will not work. How this will work? We'll have to teach you dynamic array list also. So and then give you some 10 minutes for Q&A. So let's move really fast. So your algorithm will not work. You have seen that, Madhav. So what you can do, there is a technique when you let's suppose reverse an array, right? So for reversing an array in place, you use 2 pointers technique, right? This is what you use. Now think in terms of that if we have only three types of elements, 0, 1, and 2, can we use 3 pointers? This is how you can think. And obviously I'll say that if you have not practiced much, it will be very difficult for you to come up with this is the unique, or if you have not studied it first. By the way, this, so you think of this like, can we do it in 3 pointers? And by the way, this is very standard. This is Dutch National's algorithm, okay, which uses 3 pointers. So that's what I was emphasizing with you. When you learn data structures, just don't go by data structures and solving X amount of questions. You should learn about these techniques. Uh, 2 pointers techniques, 3 pointers technique, Dutch national algorithm, Floyd Warshall's algorithms, and a sliding window pattern, and hare and tortoise pattern. So all those things you will be getting. Okay, you should practice and know. Okay, sir, we have two arrays, low, high. With 0, we can swap it with low, and increment 2, swap it with high. There is, yes, some kind of this, but some glitch is there. We have to use 3 pointers actually. Low and high is okay. This is called Dutch National's algorithm. So let's suppose you have first pointer here, you have second pointer here, and you have third pointer here. So let's suppose this is low, this is mid, and this is high. Okay. So now what you'll do, how will you do this? Quickly, I'll tell. Since you have three, now you'll see that if your array of mid equal to 0, okay, swap it with low, and what will do, low plus plus and mid plus plus. That means you swap it with low and increase a pointer by 1. If your ARR of mid equal to 1, you don't need to swap because that's what it is in. So that's how it should happen. Like all the lows are all zeros. So you have to do like this, right? जितने भी जीरो हो वो लोअर साइड पे, जितने भी वन हो वो मिडिल साइड पे, एंड जितने भी टूज हैं वो हायर एंड पे. करेक्ट? दैट्स व्हाट यू वांट, राइट? That's what we want. So think in that way, that when AR of mid is 0, that means we are considering mid is 0, यानी mid को low पे होना चाहिए, मतलब 0 को low पे होना चाहिए. तो mid को swap करना है हमको low से, and हमको low and mid 1 pointers बढ़ाना है. And अगर mid is equal to 1, that means consider it is at right position. When we write our algorithm, we'll explain you this to nothing but mid plus plus. And similarly, when ARR of mid equal to 2, swap it with high. Okay. Did you get this or not? So this is how you can actually do it. Are you able to get this or what? And what you'll do? You'll do high minus minus. And obviously, what the constraint you will put, like low should be less than mid, and mid should be less than or equal to high. These conditions should always match. Correct? So now I'll move further because we have limited time. So now if you'll arrange this particular part, let's quickly do that. This is mid, this is low, mid is 1, we'll do nothing, we'll come here. Okay, mid will come here. Now mid is 0 and this is 1. So what we'll do, we'll swap this will become 0 and this will become 1. Correct? And now mid is there and low is here. When once we'll swap, this will become low, this will become mid. 1 we increased. Now this is 2, mid is 2, we have to swap it with this. Okay, we have swapped here 1 and here 2. Now we will reduce high here. Since here it is 1, we'll do nothing, mid plus plus. Mid will come here. Now you see that this is 0 and our low is here, pointing to this one. Low is not increased, mid increased. So we will swap this. So now 0 will be here, 1 will be here, low will come here, and your mid will be here. Now it's 1, will do nothing. Now it's 2, we'll swap it with this one. Again it will 2, and low and high are equal. High bhi yahan pe, oh sorry, mid is also here, and your condition will be met. And it will come out of loop, and that's how you will see that 0 0 1 1 1 2 2 2. This will be swapped. I did it very quickly, but you can do traverse there. Have you understood that? It was a bit faster, I know, because of time constraint. Yes, actually, if you understood, well and good. If you have not, just try this. You'll get it. Okay. So next comes to dynamic arrays, which people say that the limitation which I told you, that the limitation which I told you, right? That what happens, that array is a contiguous memory location. It cannot expand beyond because these memories can be filled up. All those things which I told in the starting of the lecture here. If you'll see where it went here. Okay, this you have to told earlier. Although people say that dynamic arrays are the concept which have come and they expand their they expand their what do we say memory, correct? How do that do that? Like it's possible here, it's violating data structures arrays fundamentals. So we will say that, let's suppose array list is one of the dynamic uh, array, right, which comes in picture. So what if you have in, let's suppose the initial size of array list is 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what, how dynamic arrays work internally, they use array. So I'll tell you with respect to array list, okay, that how these dynamic arrays work. And then what we can do is traverse through. So let's take dynamic arrays में array list का example, because it also grows. So what happen when you declare a dynamic array list? Like if you are doing list of, let's suppose, integers, my list, and what do you do? New. People know here Java, right? If don't know, the concept will be similar for others also. Just writing syntax is. So when you do that, what happens internally? What happens internally is, so there will be a reference created for my list. Any language you can write. The syntax might be of Java, but concepts remain similar. Okay. What they do, they create a reference and they create some object. Let's suppose there is some object created, and that object is of type array list of integer types, right? So how that works, internally, what do they do internally? So they do, so when you see that how they implemented array list, what they do, they have a variable. You know what is the object class? Every class in Java is a sub or child class of object class, which can store any value. If you are writing an integer wrapper, so object class will be the parent class of that. So they have the array of object and its name is element data. So forget about this. This is a Java concept for now, that object and all. You remember that they also create array inside array list. So here there will be array, and if you have not given the if you have not, sorry, okay, this will not be required. Only 90 to 9. So if you have not given the capacity, by default it will be of 10. How? That I'll explain. So they have something called element data as a reference, which is a array. It's an array. Array list inside uses a array of size 10 if capacity is not given. If capacity you will give, yeah, if capacity is good, if capacity is determined, then it will create of that capacity. So this have internally, this have array list, and how that works. So I wanted to tell you quickly that how it dynamically grows, how it grows. Like let's give you that perspective first. So now you have array list, my list of some object, and internally it is using array. You don't know that what it does. So you have inserted 1, you have inserted 5, you have inserted 10, 12, 19, and then 15, 5, and 4, 3. And now this is like last you have, and you have inserted 7. Okay. So and now you're saying that array list is dynamic and you can increase it. You can increase the capacity and they grow. How do they grow? They don't have anything now in the memory, continuous memory. It's there, it's filled, and it might not grow, but it grows as we have seen. So what do they do now? If you want to insert 25 at this position, what internally they do, they create a new array. New, this is not a new keyword, this is a new array. Create another array with increased capacity, which is called new capacity. And how much they increase? So new capacity, so for new capacity equal to 50% more than older one. So if old starting one is 10, the new capacity will be 15, 50% more. 10 and 50% of 10 is 5. The formula which is written is in some way. That I'll not explain how you can do right shift operator. It's written in Java, it's written like that. Old capacity plus old capacity, OC is old capacity, right shift by 1. This is how to do. Old is 10. When you will right shift 10 by 1, it will come 5. This will become 15. So what they'll do, they will create a new array. You had this array, right? This one. Now, let's delete this. Here only I'll explain. So they will create 0 to 14. So till now, what will they do? They will copy. They'll copy 1 from here, 1, 5, 10, 12, 19, 5, 15, 4, 3, 7. Okay. And then here you wanted to insert a new element, right? And then garbage collector will manage this, collect this, like got free up the memory from here. So here, if you want to use purchase, now you will be able to use. So this is how dynamic array works. And internally Java uses arrays dot copy of function. But what I'm trying to tell you, that even in array list, the initial array which they have done is not preserved. They have to create a new one to find the new capacity contiguous memory. And here the cost is involved. So till 7, the cost of entering an element in index by index is O of 1. Like if you want to index here, but now they have to copy it again. So again, this older capacity, O of old capacity, they will take to traverse and copy. So this is also called amortized complexity. Okay. This is called amortized complexity. And then that's why it is said that array list have amortized complexity. You should be researching more about it, that inserting an element in array, even if you know array list, even if you know the index, is not always 1. It will be 1 till the capacity is not filled. As soon as the capacity is filled, it will create a new array, copy the older, and this will happen again and again. So let's suppose now you have 15, and now the next list will be of, let's suppose, 22 or 25, whatever. What it will do, it will copy again at that index. When its capacity will be filled, it will copy it to another array, delete this array via garbage collector, and assign the reference to the new one. So this is how it works. So, and everyone get clarity that how dynamic arrays like array list and all works, like how it grows in memory. So this is how array list grows dynamically. Can I get a yes? Like, we are end of it and we can start quickly. Yes, question and answer session. Okay, everyone is yes. So that's how it grows. And you can see like more about it. You can research, and this is how it works. So this is the gist of all the arrays for the topic. And now for the 10 minutes, 10 12 minutes, we can take question and answers, and any question you can ask. Aksham, you were discussing something. Ravi, if you have apart from arrays also, we can give, if you have anything related to career, full stack development, anything, we can discuss here, and I'll try to answer for 10 minutes. We'll wrap it up at 2. Do you guys have any question? And yes, guys, can please fill the feedback form. Why it is necessary? It is necessary because if I or Geekster need to improve upon anything, and if you want, Geekster, you can request that what all classes we can do next time. And if you want to, really explore the and want to get into full stack development and want to fast track your career, and you are looking for some guidance, you can definitely, I'll say that, go through a demo class and see that how it works. And in demo class you will get more clarity that whether you are aligned to that or not, all those things. So I say that explore all these opportunities when you have time. So yes, Ishika, how to switch from one good product company to other one? If you are already in one good product companies, you will see that, do you want to, let's suppose you are a front end developer and you want to be a back end developer, or you want to be a full stack developer, then definitely you should consider making some real coding projects by yourself, and then learning data structures algorithm, and then learning system design. These things will help you, and then you can make a switch from one company to another, and even you can transition your technology also somehow. And demo classes are completely free of cost, so there is no harm. Also, you can go ahead on this link which is given. And whoever, someone again asked one question, but I think that I deleted. Okay. So this is how, Ishika, you should be switching, like data structure, system design, your project. How to choose project? Somebody asked, I think, based on your stack. For example, if you are a full stack, or you are a backend developer, or you're a front. So if you are a front end developer, if you are starting, or even if, you can start with, right, creating your own dynamic portfolio on React or Angular, and then publish it as a website, and in the resume you can show that. And then similarly you can pick up some backend projects, and similarly you can pick up some full stack projects, and you can put that on GitHub, and then you can showcase while giving interviews. And also, this is how you can choose your projects. And is Saksham there, or he left? Not sure, but he was saying that his friend, actually, so which company, Saksham, your friend got placed, which is a very good thing. I hope he would have attended few of the classes, all those preparation materials. He took advantage of that, and that's why he got a 40 LPA package. And it is 30 to 40 LPA is feasible. So I can relate that companies are giving this much package. Ishika, I think when you write a feedback form, there will be column. You can write your suggestion there, if they'll be happy to provide that. Yeah, Autodesk. So good that how starting from scratch in Java backend, or how to start from scratch. Yeah. So if you want to start from scratch, first learn core Java, and then learn all the internals. Like I told you about array list here, there are collection framework and all. Then once you have a good understanding of Java, you should learn a framework called Spring Boot, and definitely try to start with very smaller project, like how you can build a API which do login in Spring Boot. Like you give username and password in request, and in response you will get okay, that okay, this user is logged in or got So that's how you can start from scratch. So first, I'll say that don't go for Spring Boot directly, Ravi. What worked for me, now I don't work in Spring and Spring Boot from last 1.5 year. But before I used to do for 6 year, I did that. I learned first Spring and Spring MVC architecture, and I will suggest that you will also do the same, and that's how you grow beyond that. How to learn complete data structure from you, you can connect with me on LinkedIn. We can discuss there also, like if you want to learn, and you and keep continue coming in Geeksters classes also, and explore whatever you get here also. All these things you will get to know. And my LinkedIn ID I can post for your all reference. If you want to connect, you can connect with me. This is. And do please do fill the feedback. I will also get to know that how much I'm able to deliver. Yeah, thank you, Geekster. Uh, uh, yeah, I've given this is the ID posted. And how can I host a website and which data is so Shaktini, this is very like question which is straightforward answer is can't be given, but depends on what website and all you're doing. But if you are very making very simple website, you go with any framework, front end back end APIs के लिए, front end के लिए, and then database में you can use MySQL for very smaller amount of data. Don't get complicated. First start with using MySQL. Then when you work in REST, you work on complicated projects where you want to get the analytics data for performing analytics, all those, then you use Hive and all. But I'll not suggest you to do here. Just go and start simple from MySQL. I'll accept everyone's request on LinkedIn later. But yeah, uh, that's about it. And if you have any question, other I'm there for 4 more minutes. Let's do it. Any other questions? Have I missed anything? And are not very good in finding the best optimized solution. Ravi, I have seen that, but there you are starting. So when you will practice, right? Like you have seen that you have given some approach, and I have immediately told that which edge case it will fail. So to be honest, like it took time for me to get that level of understanding. So don't get fascinated. It's not only 1 or 2 months effort, it's years of effort. Con- Consistent effort. So don't think that you will be master in 1 month or 2 months. It's a consistent effort, but I'll suggest that 3 to 4 months you practice and crack some company and continue doing practice, because this is your career, and career span is of 30 minutes. And do invest yourself on yourself. Like if you want to learn something and you found that there is uh, something you can invest on, and then you can work on this. Yeah, if you want to buy any subscription you are finding worth, not like lead code subscription and all. But if you are thinking like earlier, I used to my friends used to buy some courses, some subscription, we used to read all those things you can do. And this is really a continuous approach. Practice and do not give up. That's how you will do. Can you suggest some websites for preparing array and string concepts? There is okay. So there is no like I cannot say that this is a jotted down material, but this is like I studied in my classroom when I was doing BTech and all those things, and then I have studied complete things from standard books. For example, data success algorithm from Som Shree's Lipshus. That was the standard book which I read. For C, I did not read any local author's book and all. I directly read Denius Ritchie's C. For algorithms, I directly read Corman's standard book. And so I have one section. Lead code is good for practicing question, which is very good. You can practice there. Uh, to your information, till this date, I have done only 99 questions on lead code, and I want to complete the century. But I'm one question away from it. So numbers doesn't matter, but yeah, your thought process, your approach do matter. So that's about it. I think we are on time, and I've addressed all the questions. If you liked the webinar or the masterclass, I would advise that as a token of appreciation, since it was completely free of cost from Geeksters, can you, if you want, if you really like the content, give kudos to Geekster or kudos to me on LinkedIn, tagging Geekster, so that they'll also get motivated to organize a lot of good stuff for you. Okay. Lalit, I don't have LinkedIn Learning now. I used to do it, I think, 3 4 years back when I got it from some corporate. So I'll have to see that what all courses it has. I've really not used in 5 years now. So that's about it. Happy weekend all, and okay, I'm leaving. Bye.